Welcome to this DigiPara Liftdesigner for Autodesk Inventor Cabin Configurator tutorial. This is the second video, and in this video we concentrate on the ceiling of the cabin. This tutorial will show you how you can automate a cabin ceiling with DigiPara Liftdesigner, and we have 5 basic steps. We review the ceiling and the wall panel options within DigiPara Liftdesigner. We have to prepare the Autodesk Inventor ceiling part. We then align and resize the ceiling according to the car size and add the ceiling to the Liftdesigner database. The main challenge will be align the ceiling and wall panel holes. First of all, I have adapted the car wall panel, not in this example, up front. The car wall panel has always 2 holes, and each hole is 60 mm from the outside of the car wall panel, and the wall panel as it is defined is valid for a width larger than 170 mm. There are several ceiling limitations in this demo. We only concentrate on the holes on the right wall. We limit it to up to 5 wall panels, and there is no check for minimum car panel width. I understand that you sometimes have 1 or 3 holes in the car wall panel. The implementation for that would be more complex, but more or less the same. So it would not show any new concepts, so the concept is the same. Therefore, we only concentrate on this 2 holes version. So let's review the ceiling. So I already enabled the ceiling component by setting create geometry equal create. And if you see the ceiling, you see this red geometry. The ceiling itself consists of 2 main objects. One is the ceiling geometry, and one is an optional list of panels this ceiling consists of. So if you see panels, you see under panels you have a list of panel rows, and each panel row itself has panel items. It's important to understand that. And in Liftdesigner you can define the number of panel rows and columns. So here on the right side we have ceiling panel columns and ceiling panel rows. We have 3 rows and we have 4 columns. So if we reduce the column count, let's say to 2, we need to update the model, and then you see what happens. We only have 2 panel rows here on the left side, and each panel row still has 3 columns. So we might change that to 1 by 1. So if we have a very simple ceiling, we might change this to 1 by 1. Then we have just 1 item, and in this case we have some geometry, ceiling based geometry, which is more like a frame, and then we have 1 panel in between. We can also go back and say the column count is 0. This would mean that we have no ceiling panel rows, and then we just have the frame. And this is actually what I want to do. I will replace this frame in the example by the geometry that is delivered as cabin design. So also we want to have a look at the wall panels. You see we have 1, 2, 3, 4, 5 wall panels. And if we select the wall panels, we have selected 1 single wall panel item, and a basic setting is at the wall right, and there we have a default panel width of 444. So if we change that to 333, just as an example, and we update the model, then you see that we get additional items. That is clear. Let's update that. I have to update second time here. And then we see we have 1, 2, 3, 4, 5, 6, 7 items. And I go to Find in Browser, and then we see this is wall number 4. And we have from panel 0 to panel 7, which 6, which means we have 7 panels. So what we have here, if we view the last panel, you see it's 102 millimeters. And this is not according to our specification where we said, okay, the minimum size is 170 millimeters. This is probably not the 100% solution, but I want to show you what happens, because the default panel width is 333, and the maximum panel width extension means the maximum overall width of one panel might be 433. And what we can do is, if we put 170 here, we might get a panel that is 503, so the sum of both as a maximum, but at least we will never get a panel that is less than 170. So when I update in the next step, you will see that this panel and this panel, so this panel simply becomes larger, and this is will disappear. So let me update that. And you see now we have one panel that is 435, and then we have the 303 items. Another important option is that you can tell the system where the panel arrangement starts. So at the left corner is this corner here, and the first panel starts at the side, and there are very many options. One typical option is at the COP, means that it starts from the COP to the left and to the right. But just as an example, we can start at the right corner. There is a good option at the car frame. It's very important if you have one panel that is exactly centered with the car frame. This will automatically move your design according to the car frame position, and in the car center, and some other manual option. But let's start in the right corner just to see what happens. Then the first item will become the large one, and the other items are the small one. Okay. Let's select this car operating panel just to show you what happens. So if I move the car operating panel into the right wall, and we update, then what happens is that the number of panels here on the right wall will probably change, or at least the size will change, because there is a panel option that says integrated into wall, and integrated into cab wall means yes. So let me update this a second time. And now we see we have 1, 2, 3 items, and the small and 2 large typical items. And now it's a good option to tell the system that it starts at the COP. At the COP. You see, this is the small one, but we probably want to have the small one on this side and here on this side. So if I choose at the COP and update that, then you see what happens, that we have the typical sized COPs here, and the remaining part here. So this is also 333 from a size, and this remaining part is 309. It's difficult to see here. This was just an introduction. We do not concentrate, with regards to the ceiling, we do not concentrate on the holes at the car operating panel, but at least this is a challenge that we have to find the right hole positions for these 6 items here, but I will exactly show you how that works. Before we can start creating a new ceiling geometry, we have to replace this Cabin Components ceiling with our own one. So we have to copy this ceiling, and this is similar to the wall panel. We have to go to Data Manager, and there is one item called Cabin Ceiling, and we simply will copy one of that. The simple type here, the first one. So we say create a copy of this ceiling, and we copy this into my cabin manufacturer. And once everything is copied, we go to this ceiling. And let's have what we have. We have a manufacturer. This is my simple ceiling. Let's say that is type number 1. And the ceiling panel group says which is this single ceiling panel items, and we simply can set this to 0. 0 means that no panel group is there, and we set the trapdoor also to 0, means there is no trapdoor, and 0 ceiling lights, also 0, there are no lights. So we can only concentrate on the geometry. And now I will load this product. So I go to the ceiling and I load this new created product from our own library, my cabin manufacturer, type number 1. Okay. And then you see what we get here. We have it looks okay. We have to update, but it looks exactly the same to what we had before. And we have a ceiling. There are no panel rows and columns below. It's just a geometry. And what we can do next is that we add our own geometry. So do not forget to save your project. So I will do that. Okay, and then we go for the ceiling. We go into the correct geometry path folder, and this here is what I received from the R&D department, which is my car ceiling. So I will simply copy that and copy it into this folder. And first of all, let's have a look what is inside this part. So, and we see there is some eye part. So let's make it 1400 car depth. So eye part is pretty good, but not for automation within DigiPara Liftdesigner for Autodesk Inventor. So I will delete this table. And if we review that, you see that on the right side there are already some holes. They are not properly placed so far, but just as a start. And what I also want to do is I want to change these parameters. So the car depth is 1400, and I go to manage parameters and I give it some better name. So this is my car depth, and the other value is my car width. So this is not necessarily required, but it's a good idea to give it speaking names. So I save that, and now I'm ready to load it into my model. So we go now ahead and modify the geometry object. I go once again into this folder just for me to copy this folder name. So it's very important that you take the ceiling object from the correct folder. And now I say place, and you know, now I can paste this folder name here, and then I can load this ceiling and I place it anywhere, and then I'm done. And we can delete the default geometry from this. And now we have to align the origin of this geometry object and the origin of the folded model. So we have the plane. This is the ceiling plane. So we do a constraint between this plane and this plane of the ceiling. Apply. Okay, it's a wrong direction, so I go to mate. I go to this mate and say edit. It's opposite side. Okay, that looks good. And now we have to align the next plane. So this is the front left corner of the cabin, and I do a constraint to this cabin ceiling plane. Apply, and you see the location of this plane is not good, so it's the wrong direction because we want to have the hole at the front. So I go here and say edit. We turn it around, but it's still the wrong location. I'm showing you this by design because you might also have the same issues. So what I will do is now I go into this ceiling and I modify the ceiling. So we have slightly adapted the car ceiling. You see we have a sketch here and we have a base point over there. Liftdesigner has a base point for the car ceiling on the front left corner, means this corner. And the only thing we need to do is we need to add some constraints here. So we have to put this point here. Let's do some constraint here. This point to this point. And oh yeah, we are done. That's all we have to do. And we say save and go back to the project. And yeah, that looks pretty good. There is one constraint missing. So we continue now setting the constraint, the front wall of the cabin, and we do a constraint to the front wall of this, the same direction. Okay, cancel the operation. That's our this object and this, and then we have to say opposite, apply, and then it's on the right position. And you remember last time it was pretty easy to add some mapping. So we go to mapping, parameter mapping, and we say we do a manual mapping, and we do a mapping from the car. So we are at the car ceiling, but the car size is at the car object, means me is the ceiling, parent is the car, and there we have some car width parameter, and the target is my car width, and the same is for the car depth. There is a car depth parameter, and we paste this on my car depth, and yeah, then we're done. Save everything, okay, return, and if we now update all, you see that the ceiling has the right size. So we can, let's try that. Let's change the car size and see whether everything works as it should. So if we go to a car width of 1450 and the car depth of 1840, just as some sample numbers, we update everything. You see that the wall panels at the front, or here at the right wall, are updated accordingly, and that the car ceiling gets the correct size. So usually you have to click update twice, and that looks good. So what we do now, so that we have saved that, we go to this car ceiling, find in browser, and yeah, we go to the gear object and say save to database. This will save our, you see this folder here, which is the folder inside the database folder. So this is the data pool. This is my data pool number 4 in this example, and there we have these Inventor folders, and here we save the master part. Save. So all these parts are now saved successfully in the database. So next we want to synchronize the holes, and the holes of the ceiling and of the car wall panel, and I have prepared this ceiling somehow. So let me open that file and have a look from here. We see we have 2 holes, and this is cut number 19, and I have a sketch, and I call this sketch panel 0 right. So we are concentrating on the right wall, and it's the first panel, and the panels always start with the index 0. So this is panel 0, and probably it's a good idea also to rename that. Cut panel 0 right. And let's have a look at the sketch, what I did here. Okay, for any reason that's the wrong direction. So what I have here is, I did this left one. This left item is defined as symmetric. So if I change the size here to 30, you see it's increasing. If I change that to 14, everything is increasing properly. And also you see on the right side, this is also updating. So if I change the width, take care on the right side, it also decreases. This is because this is a center line, and there is a rule for this center line. It's 0.5 multiply panel 0 right width minus 60. This is exactly according to what we had in this for the definition for this hole. 0.5 myWidth minus 60. So the distance from here to here is 60 millimeters. And this is the same what I did here. I introduced 2 parameters. So if we view on manage and then parameters, you see I have panel 0 right width. So panel 0 on the right side, the width, and panel 0 on the right side, the x0 coordinate. The x0 coordinate is the distance from the front wall to the center of this first panel. And then I did a cut, and that's all I need to do. So let me complete that. So this is my my ceiling. I saved that, and I want to complete that process now here so that you understand how that works. So what I do now is I add an additional mapping. So I go to parameter mapping, and I think you can remember initially we adapted the car size, the car width and car depth to our model parameter my car width and my car depth. And what I can do is I can do a new group here. It's not necessary, but let's call this right wall panel sizes, and I can create a new action. And now the action is not related to the ceiling. I have to select the wall number 4. Remember, wall 4, index 4 is always the right side. And there is a panel 0, and the panel 0 has a property that is the dx, which is the width, and we assign that here to our model to the panel 0 right width. And then we need the location, means the location from the left, from the front wall to the center of the first panel. It's quite similar. This is something you need to know how it works. So it's the wall 4, it's the panel 0, and then the panel 0 has a local matrix, which is a relative coordinate, and then it's r. R means the base coordinate, and then it's x. So this is the location to the center point, and we need the user parameter x0, and then we're done. So that's all you need to do to synchronize that. And if I update this now, you see what happens. The holes are properly synchronized. So let me try something else. So I go now to the right, to the wall, and change the width to 444. So we increase the size of this panel, and when we update this, you will see what happens, that the holes get aligned properly. Can you see that? So what I did, I moved this ceiling somehow up 100 millimeter or 50 millimeter up, just to make it better visible that these holes are fit. So let's try it for the second. I want to extend this example for the second panel now. So I will now concentrate on the holes for the second panel, which is panel 1 on the right side. And therefore we have to add some sketch. I choose this, let me rotate that, I choose this, and then I copy that here. I copy the existing sketch and paste it here. And okay, let's move this. Let's move that to the right side. We don't need that. And you see we have a rule which is D368. But what we want to do is we go to manage and rename that. So I go to parameter, because we need a panel 1 right width, and we need I think we don't need these parameters here. Manage, delete parameter, delete parameter, delete parameter, and we need an additional. This is blah. We need an additional panel 1 right x0, and let's put this at 800, just that we have an initial value. Done. And now we can we go to edit sketch. We add a dimension from this base point that I declared here to this point, which is the base point. And then we choose the parameter. For panel 1, the x0 position, which is the center position. And okay, so we are ready with the sketch. We rename this sketch. It's not necessary, but it's a good idea to rename that. So this is the sketch for panel 1 on the right side. And yeah, now we go ahead and make a cut. This and this. Okay. And we also rename this. So this is cut for panel 1 on the right side. And then we are done with this second stage. So we are now going back to the car, and we simply have to add a new mapping. I mean, the process is now always the same. We add 2 actions for the right wall, panel number 1, the dx value, and we assign that to panel 1 right width. So it's a good idea to work with a clear naming scheme. And wall number 4, panel 1, local matrix R, and then the x coordinate. It's always x coordinate for all walls, so don't be confused, it's always x coordinate. And then choose panel 1 x0, and then we're done. So let's update that, and you see everything is aligned. And now I want to show you something additional. That's amazing. So I will, in the next step, I will extend this without showing here for the other 4 items. So that is the result I have modified so that we have cuts for every panel. You see here on the right side, for every panel there's a cut. I have properly named everything. It's important in such a project that you use a good naming, otherwise you get lost when you have to maintain that. And if you view under manage, under parameters, you see also here I have a clear naming scheme. What I also had to do is, since I wanted to bring in 5 panels, I had to increase the car depth. So usually when you develop such a thing, you need to develop for the maximum, and then you need to have the maximum car size so that everything fits properly during the development. So then I'm done here, and I go back to my elevator model, and now I have to go ahead and do the mapping. So you see what I'm doing here. You can easily select one item, you can click on copy and then on paste. Then I get a new item which is still panel 2, but then it's somehow easier to find the same thing. So it's now panel 3 and the x dimension, and don't forget to adapt here. The target variable is the panel 3 width, and then also this position I can copy and paste, and then I choose the same item for panel number 3. So panels from number 3, local matrix R, and here is also panel 3 x0. And now what's now? We have 5 panels, but we can only assign 0. We in our project are only 4 panels, so it's important when you do the mapping that you work with the maximum items. So let me update here. We just have 4 items. So what I need to do is I need to actually I need to do something different. So the result so far looks pretty good. What I do now is I change the default size to 333. This makes sure that we get more wall panels, and then we have sufficient wall panels to to do the mapping as we would like to see. You know, this example is limited to 5 items, so I will not concentrate on item number 6. It's the same concept, same principle. It's up to you to fix that. But now we have item number 4, which is the 5th item. So I go to parameter mapping. Okay, that's parameter for the wrong object. Don't forget to choose the correct item, which is the ceiling, and then we go to parameter mapping. And yeah, I do the same thing. I copy this, copy paste. It's not panel 3, it's panel number 4. And then I have the width of panel number 4. And I do the same for the local metrics. Copy, paste. And this is panel number 4. Local metrics are the x value, and then it's panel number 4, right, x0. Now I'm done. I update everything, and what I saw is that it didn't work, and there seems to be a small issue here in the software. So 1 second, switch between 2 components back and forth, go back to the ceiling, and then you see, due to this copy operation, that something is wrong here. So for the source value, choose properly the x and x0. So we will fix that in the next version. But for the time being, so now update all, and you see it's done. It's amazing to see that it doesn't work just for this object. What you can also do is now I just want to show you that if we add some car operating panel in between, so I go to the car operating panel. It's currently set to do not create. I say create, and let me update that. And then you see that the car operating panel is on the opposite side. And what I can do is I can put it in the right wall. And now we update that, so it puts the car operating panel in the right wall. And you see we have now 5 items. Everything is aligned properly. It doesn't matter what the size, it doesn't matter where the location is. We have now everything under control. You need to do a very similar thing for the car operating panel. So the process is the same, and I hope this was helpful for you. So this is the end of this chapter that explains alignment of holes of the car wall panel and the ceiling. If you have any questions, do not hesitate to contact us.